Today's objective is I can invent a number system by creating a systematic order for permutations. A big objective sounds kind of fancy, but it's a really simple and short lesson. So today we start off with a video. This guy does a much better job than I could at explaining how permutations work. A confusing thing about this video and today's lesson is the semantics of combination. I think back to a combination lock I use for my bike. The order does matter on that lock. So it should be called a permutation lock, because in combination the order doesn't matter, but in a permutation it does. So now anytime you see a lock, you can tell a friend what its real name should be. Here's some video notes. The difference between permutations and combinations are covered. Permutations use factorial, so with a max length of 3, you would have 3 factorial possible permutations, which means 3 times 2 times 1, which is 6, so 6 permutations. The max length is obvious, or else would be in infinity, so there's that. Factorial for permutations are always used for permutations, and permutation is just a fancy word, so it deserves an exclamation mark. Get it? Math humor. So permutations, big word, but it's not too tough, and doing factorial is not too difficult either. So if you're getting a little nervous thinking we're going to start using a lot of math in this class, don't worry, we're not. So we use number systems for counting. The number system you are familiar with uses permutations of the symbols 0, 1, 2, all the way to 9, okay? As well as a set of rules about that order. Develop your own number system using circles, triangles, and squares. To do so, you'll create rules that generate every possible permutation of length 3 that can be made with these shapes. And we're going to have to cap it at 3, or else obviously we could go into infinity. Shapes can be used multiple times within a permutation, and order matters. For example, the picture to the right shows several different permutations. Note that the first two, which both have 2 squares and 1 circle, are considered different because the shapes appear in a different order. Make an ordering for the permutations. Now that you've listed out all of the combinations of circle, triangle, and square, let's put them in a systematic order. You can use any system you like as long as you create and follow a clear set of rules for getting from one line to the next. It's another name for a set of rules. Jot down the rules of your system. I suggest to test your rules, have someone follow them to see if they can recreate your organized list. So now at this point we're going to play around with this widget called the odometer, and it's pretty fun. Before you play around with it too much though, I want you to do a think, write, share, make a prediction. Which number system will take the shortest amount of time to max out the odometer? And a great example of the importance of permutations is in Roman numerals. So Roman numerals use a decimal system with 2 and 5 as subbases. So the Roman numerals are trickier than your average number system, okay? These types of number systems are called biquinary, and is found in Wolof, so in Senegal, and Khmer, which is Cambodia. And Roman numerals are a biquinary system, like I just said. So the rule is, if the smaller number is to the left of a larger number, then it's that much less than. If it's to the right, it's that much greater than. So you're using base 2 and base 5. Permutation, again, it's an ordered arrangement of objects or symbols. A number system is a collection of symbols and the rules for ordering them. In case you didn't know what the Roman numerals stood for, there you go. So now you could decipher any Super Bowl you see. And that's it. So a short class today, mostly focusing on permutations and creating them. I want you to turn in the rules to your number system and then answer what is your favorite number system and why.